Today we're learning about permutations. So first let's recall we will be using, you all know about factorials, so just remind you that let's say 3 factorials is 1 times 2 times 3. So n factorials is 1 times 2 times 3 times n minus 1 times n. You all already know that. And permutations, no, first of all, let's start from arrangement. Arrangement is in how many ways we can arrange an object in a row. We can, pretty much it's a permutation. So what is permutation? Permutation is P and R, that's notation. If we are finding the way how we can choose R objects out of N objects if order is important. If order is important, that is permutations. For example, if we choosing, let's say, the class you're choosing committee, where it should be chairman, secretary, and treasurer. Because it's all different position, and there are, let's say, 10 people in the 20 people in the class. So how many choices we have for chairman? There are 20 people in the class. We have 20 choices for chairman. How many choices left for secretary? 19. And how many choices left for the treasurer? 18. So that will be permutation of 3 out of 20. So when the order is important, because it's important, it's not just committee of 3 people, one of them chairman, one secretary, one treasurer. So permutation is when order is important. And going to the general formula, that will be n factorials divided by n minus r factorials. So applying to here, we will get that permutations of 3 out of 20 will be 20 factorials divided by 20 minus 3 factorials, which is 17 factorials. Everything below 17, from 17 and below cancels out, and we have what we got before. So if we're just looking for number of arrangements in a row, in how many ways we can seat 10 people in a row?
10 factorial.
10 factorial. So if we arrange in a row n objects, we can arrange them in a row in n factorial ways, because we have n choices for the first place, n minus 1 for second, and so on. What about arranging in a circle? So if we have a circle and we want to seat n people around the table, in how many different ways we can arrange, not in a row, but in a circle?
N minus 1?
That will be n minus 1, because 1 will be repeated. Not 1, like one arrangement, if you turn each round will be repeated. So in a circle, it's n minus 1 factorials. Example. Let's consider the next example. So let's say the club will appoint a president and a vice president.
Damn.
That's from your booklet, 9b, example 3. So club will appoint president and the vice president. 8 people put their applications for those 2 positions. In how many different ways these 2 positions can be filled?
56.
We have permutation of 2 out of 8, so that will be 8 factorials divided by 8 minus 2 by 6 factorial, which will be 7 times 8, which is 56 ways. Make sense? Now, for 3 years, the same 8 people volunteered for those, put application for these positions. Determine the probability that one for 2 years.
2.
So for 2, not 3 years. 2 years. What is the probability that one of them will be president both years? So, for 2 years, president position, how many ways we can fill the choose president 2 years in a row? In how many ways?
1, right?
No.
1, 2.
No, third. We have 8 people.
Mm-hmm.
In how many ways we can choose chairman? 8 people, so 8 ways. Second year, we still have 8 people. So which principle we need to use, multiplication or addition?
Multiplication.
Multiplication. Multiplication because it's and.
Okay.
The same person is the chairman first year and
Mhm.
second year. So we have 8 times 8. So there are 64 different ways how the chairman can be, or president can be filled, can be the same president 2 years in a row. Now,
56 and 64?
there are 8 choices.
No.
There are 8 choices for the same person to fill the position 2 years in a row, because we have 8 people. So what will be the probability that the same person will be 2 years in a row? We have altogether, we have 64 possibilities. Out of them, 8 is that the same person. So what the probability?
1/8.
8 over 64, 1/8. So probability that one person will be chairman
But why is
twice.
it 8 ways?
Isn't it? I thought there's only one way that he's twice chairman.
No, it's like any of them are twice.
Any can be twice. There are 8 people, each of them can be twice.
Oh yeah.
That's why it's 8 ways how the same person can be chairman twice. So that is permutations. Today we're looking only when there are no restrictions. So can be choose anything. Next lesson we will look into the permutations with restriction when there are certain choices cannot be made. So how to deal with the permutation with restriction. But that's all about permutations for today. Like, subscribe and donate to help fight terrorist countries and organizations, Russia, Hamas, Hezbollah, Iran, etc. Support Ukraine and Israel.
Yes!